Page 21. So now we're really focused on geometry. So today's lesson is going to be over 2 theorems that we use to prove that triangles are congruent, okay? There are like 6 theorems that we use. We're going to learn 2 of them today. And we're not doing a lesson tomorrow, right? Because tomorrow you're going to take your 4.1, 4.2 quiz. Remember, tomorrow you're going to take your 4.1, 4.2 quiz, which is why I created that Delta Math assignment, because I said the assignment was your quiz is going to be online in Delta Math. And so I asked that you at least peruse that to make sure you could do those. Do you guys remember that? Okay, so here we go. Congruent triangles. Well, let's talk about congruent polygons because a triangle is a polygon. So the definition of congruent polygons is all of the parts of the polygon are congruent to the corresponding. Oh, okay, I'll fix it. They're congruent to the corresponding parts of the other polygon. So in order for triangles or any polygon to be congruent to another polygon, all of their corresponding parts have to be congruent. Let's talk about what their corresponding parts include. Well, when you look at these triangles, they have 3 what? What am I circling? They're actually angles, right? They have 3 angles and 3 sides. So when we say that the corresponding parts have to be congruent, that means that the corresponding angles have to be congruent to each other and the corresponding sides. Now, there's a trick to this. You can actually do this without ever even looking at a picture. So we'll talk about what is congruent to each other. We'll write it out, and then we'll show you the trick. Because, we'll do it the hard way first, and then we'll do it the easy way. So it says triangle CAT is congruent. Remember, that's the equal sign with the little squiggle. It's congruent to triangle DOG. Okay. So let's just look. That means that angle A is congruent to angle what? Angle O. It means that angle C is congruent to angle D. It also means that angle T is congruent to angle, okay? Now we're going to talk about the sides. Let's see. Segment AC has to be congruent to segment OD. And segment CT has to be congruent to segment DG. And segment AT has to be congruent to segment OG. Okay, so I'm going to write CAT and I'm going to write DOG because that's exactly how those 2 triangles were named, right? Notice that the first letter is corresponding to the first letter that represents the angles. C corresponds to D. Angle A corresponds to angle O. Angle T corresponds to angle G. Does that make sense? The way that it's written? It also means that segment CA corresponds to segment DO. Segment AT corresponds to segment OG. And it means that segment CT corresponds to segment DG. And that's what we wrote. But you can do it based off of the way that the triangles are named as being congruent to each other. You don't even have to see a picture. Okay? Are you guys understand what I'm trying to say there? Yeah. Hey. All right, took a bite. All right. So the definition of congruent triangles says that triangles are congruent if the corresponding That's not spelled right. Corresponding parts of the congruent triangles are congruent. So anytime you're given that triangle CAT, for an example, is congruent to triangle DOG, you want to automatically be able to say, well, that means that angle C is congruent to angle D. And the only way that you can do that is if you write out that reason all of the time. Corresponding parts of congruent triangles are congruent. Who wants to write that out 100 times in one proof?
Not me.
Yeah, who wants to write it out even one time?
Not me.
Me either. So the abbreviation is CP, CT, C. Corresponding parts of congruent triangles are congruent. That's how we abbreviate that. CPCTC.
What?
CPCTC.
That just sounds
Okay.
Oh, I got it.
All right. So I know this picture isn't great. So we're going to kind of look at the way that the triangle is named. We're going to look at the way that the triangle is named. So triangle DEF.
Miss Durbin sent me down here to get another sheet of homework.
I think that they are sitting right up there, sweetheart, on that little tray. Thank you, sweetie. Triangle DEF. Here, you want to do something and give her. I'm looking for the copy of the. Looking for the answers, but I don't know where they are. I know that you guys can figure it out. Tell her I'll send her the answers if she wants. Okay. All right. Thank you, dear. All right. So triangle DEF is congruent to triangle KJI. That's what that says. I know it's a bad print. So it says, hey, segment FD. Well, F is the last letter. D is the first letter. So segment FD has to be congruent to segment what? Yeah. Segment IK. I don't know why I put a thing on there. Whenever you say, like, do triangle segments or any segment, you have to put a bar over it. Okay. So the next one, we're going to look at the angles. And do you guys see these little, this has 3 marks. This has 1 mark and this has 2. This also has one side, like 1 mark, like one mark as congruence, 2 marks and 3 marks. I don't know if you guys can see that or not, but that's how they're marked up. So 1 side, 2 sides, 1 angle, 2 angles, and then 3. So when you think about it, you're just going to take, if I has 3 markings on it, triangle RST, you have to start with the angle that has 3 markings on it, which is angle S. Do you guys see that? So this is going to be triangle S. Then go to go to J. J only has 1 mark on it. So the next, on the other triangle, the corresponding triangle, the only one that has like 1 congruent mark on it is T. And then K has 2 marks on it, which means R also has 2 marks on it. Do you guys see how I do that? How the angles are marked? Okay. All right. So for each of the following, draw and label a figure to represent the congruent triangles, and then find X and Y. So anytime I have to draw triangles are congruent, I don't know why, my brain always just draws right triangles. It just is easier for me. So I just always draw 2 right triangles that appear to be the same size. I'm going to label the first one A, B, C, and I'm going to label the second one D, E, F. Now we have to put some measures in there, okay? Well, it says that segment AB is 7 units. I'm going to put a 7 right here. It says that segment BC is 9 units. So I'm going to put a 9 down there. It says that segment AC is 11 plus X. That's this guy. Now let's look at DF. Well, DF is the hypotenuse, is 3X minus 13. DE is the short leg. That's 2y minus 5. we have to solve for x and y. Well, segment AB has to be congruent to segment DB because AB and DE are named that way, right? So 7 equals 2y minus 5. So I'm going to add 5 to both sides. That gives me 12. 12 equals 2y, which means 6 equals y. Now I have to solve for x. What are the corresponding sides that are going to allow me to solve for x? Yeah, AC and DF. AC is 11 plus x, and segment DF is 3x minus 13. I'm going to subtract x from both sides, and I'm going to add 13. So 24 equals 2x, which means that 12 equals x. Questions? All right, let's do it again. Draw 2 triangles. You're going to label them LMN and RST. So LMN, RST. So the measure of angle L, that's this right here, is 49 degrees. The measure of angle M, right here, is 10y. The measure of angle S is 70. And the measure of angle T, it's this right here, is 4x plus 9. So are there any corresponding angles that we can set equal to each other? What do you think, Josue? 70 has to be congruent to, like M has to be congruent to S, right? So let's just set those equal to each other. 10y has to equal 70. What? Yeah, y equals 7. Okay. What about L? What is L congruent to? Angle L. Angle L is congruent to angle R. So that means that this is also 49 degrees. Jaden, I want you to pay attention, okay? So this is also 49 degrees. So think about the triangle sum theorem that says all 3 of these angles, because that's the only way that we can solve for x, all 3 of these angles have to add up to what? 180, yeah. So 49 plus 70 plus 4x plus 9 has to equal 180. Well, 49 and 70 is 119 plus 4x plus 9 equals 180. Let's see. I don't know why I didn't combine those. I'm going to stop for a second. What's 4x plus, what's 119 plus 9? Why did I not combine them? Thank you. 128 plus 4x. That's even better. So I'm going to subtract 128 from both sides, which means that 4x equals 52. Divide both sides by 4. X equals 13. So y is 7 and x is 13. How do we feel about those? Colt, are you with me? Are you writing down your notes? Okay, thank you. All right. So our first postulate, and someone asked me yesterday what a postulate was, and I think it was you, Tyler, and I said, it's just something that we understand to be true. And that's exactly what we're going to say. So a postulate is just a rule or a math law that is accepted as true without proof. It just is. So we're going to use SSS postulate, which stands for side, side, side. So the SSS postulate says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So here's an example. This side is marked as one congruent mark, one congruent mark. That means that because they have one mark on each side, those are the corresponding pieces. 2 marks, 2 marks, 3 marks, 3 marks. So those triangles are congruent by side, side, side. This next one isn't as obvious, but this has 2 marks on it, 2 marks. This has 3 congruent marks, 3 congruent marks. And it may help you to like color code it. I don't know. So if I made this purple and this purple and this green and this green, what can you say about that middle line? It's the shared side and it's congruent to itself. So I'm going to draw a little arrow that says this is congruent to itself. So I'm going to put one congruent mark on it. And there's a law that we use, or a property that we use, and it's called the reflexive property. So reflex property. It's the reflexive property. Because you're going to have to use that. We're going to do some proofs, so you need to know that. Okay? So we have the side, side, side postulate, and then our other postulate is the side angle side. So it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the triangles are congruent. Okay, so here is an example. So I have this side with 3 marks on it, corresponds to this side with 3 marks on it. This side has 2 marks on it. This side has 2 marks on it. And this side has a right angle. And this, or sorry, not this side. This angle is a right angle and this angle is a right angle. Okay. So when I think about it, this is side, angle, side, corresponds to side, angle, side. All right. Okay. You can't just say because they're right angles, like those angles are congruent. You have to say all. So here's like a theorem. All right angles are congruent. You can't just because they're both right use side angle side. You first of all have to say that the right angles are congruent. I know it's weird. This next triangle, I have this side with 2 marks corresponds to this side with 2 marks. And then I don't know if you can see it or not, but these angles have a little, when you put like an arc around an angle, one arc, that just means that those are congruent to each other. So this angle right here is congruent to this angle right here. So can we use the side angle side, or are we missing something? What do they share? They have this shared side, this common side. So this is side, angle, side of the top triangle, and then side, angle, side of the bottom triangle. Make that. Do you guys see that? Side, angle, side, side, angle, side. And again, that little side congruent to itself is because of the reflexive property. Okay, so now we're going to draw a picture of 2 triangles that are congruent by side, side, side. So again, I'm going to use right triangles just because I like to. I'm just going to mark the sides. This side is congruent to that side. This side is congruent to this side. And this side is congruent to this side. That's how we show that. Okay. Next, it asks me to draw 2 triangles that are congruent by side, angle, side. I'll try to draw 2 isosceles triangles maybe. How about that? Mix it up. Okay, so the most important thing about side angle side is you have to remember that the angle has to be included in between the two sides. So side angle side has to be congruent to side angle side. Okay. Thoughts? Okay, I'm going to keep on going. So if you look at this bottom triangle, I have one side, this mark, like one mark congruent, two marks congruent to two marks. It says, what information is needed to say that these two triangles are congruent by side angle side? So what is the angle that needs to be, like you need a statement that says this angle is congruent to that angle. What are we missing? Yeah, the included angle. We need to know that angle L, because that's in between the two congruent sides, is congruent to angle H. So we need angle L to be congruent to angle H. And that's a lot of your questions will be like, what else is needed to prove this with using this theorem? Okay. So this says, God, this is a horrible copy. I have to just redo all these. It's because we don't have geometry books anymore. So they just get copied over and over. Determine which postulate can be used to prove that the triangles are congruent. If it's not possible to prove congruence, you have to write not possible. So I don't know if you guys can see it or not, but this side is marked as being congruent to this side. That's all that's given. All right. But we do know something specifically about a pair of angles. Do you see any V's inside of there? Like V's pointed in opposite directions? Yeah. Yeah, this angle right here and this angle right here have to be congruent to each other by vertical angles, right? So could we use, is there another angle that we see or another side that we see is marked congruent? Can we say that these two triangles congruent? Do we have enough information? We do? We can use side angle side? No, we can't. This is not possible. Not possible. Okay. Let's look at our next one. One side congruent to one side. The two marks on the end congruent to these two. And then this is a right angle down here. This is a right angle. And we know that two right angles like add up together to 180. So this is also a right angle right here. So they both have right angles. What theorem could you use to say that these two triangles are congruent to each other? SAS? Well, then we would need to have this marked, right? Because this is the side angle side. So we could use side angle side. What else could we use? Don't all of the triangle, like don't all of the sides from this triangle right here correspond to all of the sides from the triangle below it? This side is congruent to that side, this end is congruent to that, and this is congruent to itself. So we could also use side, side, side. You could prove this two ways. Okay, you could prove that two ways. Number 6. So let's see. You know that this side is congruent to this side, and this side is congruent to this side. Do we have enough information to say that those two triangles are congruent to each other? You need to mark the shared side, and now we do. We have side, side, side. And when I think about triangles, I always start with the one mark and work my way around, smallest to biggest. Side, 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 congruent to side, side, side. So I just kind of make sure that I can touch all sides in the same order. Like, does it work? Okay. All right. Next page. We're almost done. So we're going to look at, these are going to go fast. We're going to look at these examples and we're going to say if the two triangles are congruent. And if they are, we have to say how we know, like basically what theorem. So the first thing that you always want to look at is the included side. So I'm going to look at this included side. I know it's congruent to itself, so I'm going to mark it congruent. So I have two theorems right now. I have side, 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 or side, angle, side. My third side does not have a marking on it for either triangle, so I have to see if this follows the side, angle, side rule. Oh, none of you guys do? Oh, you know what? I do remember that. Hang on. That was a printer faux pas, and I caught it in the middle, so I did print that page for you guys. Dang it, I love it when I have my brain on. Right?
Yeah, what the heck?
I know. You believe that?
I'm always believing.
Okay. So it's page 23. Who doesn't have that side? Yes, you need it as well. Okay. Sorry about that, guys, y'all.
Good job. Dad.
Andres, yes, you need it. Okay. 1, 2. Anybody else? That's it?
I got page 23.
Okay. There we go. Page 23. Okay, so let's look at this. Side. So I have side, angle, side. Side, angle, side of the triangle that's facing down, but I also have side, angle, side of the one that's facing upwards. So we can say that these are congruent by side, angle, side. We don't have to, like, everything is marked the right way. So this side is congruent to this side, and these two angles are congruent to each other. We know that the middle piece, the shared side, is congruent. Does this follow the side, angle, side? Well, the top one does. The top one follows side, angle, side, but the bottom one follows angle, side, side, and that spells booty, and there is no booty postulate.
What?
It spells booty.
Booty?
Yeah, do you see that? Well, you know what it spells. We don't have a booty postulate. So this is not possible. Yes, it does. Shh. No booty postulate. Okay. Number 3. Let's see, we have our shared side. So side, angle, side compared to side, angle, side. So this one is good. What about number 4?
No.
It's good on the first one, but the second one it fails. What does that tell us about? Do we have that postulate? No booty postulate. We cannot spell ass in our homework. Don't do it.
Nope.
You did it. Don't spell it. Okay, what about this next one? This is common side, right? So side, 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 side. This works. What about this next one? Yeah, side, side, side. Ooh, that's already marked like that. Let's just have one mark. So side, side, side. I used to have a student named Samuel Soley Swingley. So we used to call it the Samuel Soley Swingley postulate. That's a mouthful. Yeah. Okay. So what about this one? Yeah. Side, side, double, double. Yeah. This is a side, side, side. What about this guy over here? Yeah. Side, angle, side, and then side, angle, side. So SAS, a little bit of SAS. What about this one down here at the bottom, number 9? Yeah. Because I have side, angle, side right here, but what happens in the bottom triangle? It spells SSA, or booty backwards. Not possible. Okay. What about this one? Number 10. Side, angle, side. Are you guys understanding this? Are you seeing how they're marked? Okay, you're seeing it? Number 4, not possible. It spells ASS, and we don't spell that in math.
Nope.
Or any other class for that matter.
Actually.
Okay. Here we go. This is it. This is the last one right here. Here we go. So it says, what additional information is needed to say that these two triangles are congruent using side, angle, side? Well, we only have sides marked congruent right now. I know that these two angles are congruent to each other because of why? What? They're vertical angles. They're vertical angles. So in order to follow the side pattern or side angle side pattern, I need to know that this side is congruent to this side. I need to know that JI is congruent to EI. All right. So Cole, you ask me every day if Carter can sit next to you, but you put your head down every day and then you say things like, how many more pages do we have? And you're not even focused. So pick your head up or you're not going to sit there. Got it? Okay, next. What do we need? What do we need to use side angle side? What's missing?
The angle.
Which one? Angle L has to be congruent to angle H. Because remember, it's got to be the included angle. It's the one that's in between the two congruent sides. What are we missing for number 13 to use the side postulate? Yeah, we're missing DX and YZ. Segment DX has to be congruent to segment YZ. Because this is the shared side, right? Do you guys see that? This is your shared side. So we know that this is congruent to itself. So you're missing, this is your missing piece. You're missing this and this. What about does that make sense? Okay. What about number 14? How about RT? That's right. Segment RT has to be congruent to segment ZX. Yeah, sure. What else? What about number 15? Yeah, this side has to be congruent to this side. We have to have that W is congruent to ZX. Side. What am I missing? Perfect. GEWY. Why? Because side angle side, what are we missing? This side is congruent to itself. So we're missing this angle and this angle. Do you guys see that? So notice that we've been naming angles really by a letter by itself because we haven't had a shared angle or a shared vertex. So when I name this angle, I have to name it by the side vertex side. So this is EFG. Angle EFG has to be congruent to QFG. Angle QFG. When you look at an angle that has 3 letters, the middle letter is always the vertex. If it's not, then you named it wrong. The middle letter is always the vertex. Last one, number 18. What are we missing to use side angle side? Huh? We're missing an angle. Well, we know that these angles are congruent by what?
Vertical.
Yep, these are vertical. So we're not missing an angle. What are we missing? Yeah. Go ahead. It's got to be the side that's like the angle has to be in between the two sides. DS and TS. Segment DS has to be congruent to segment TS. Okay.